Okay, so everybody, welcome to binarysearch.com. Today we have weekly contest 41. And before we go, I just wanted to say, it's most friendly and welcoming community regarding interview preparation. Certainly not the largest one if you compare with LeetCode or say Algo Expert, but it's very friendly and welcoming. So atmosphere here is just very cozy, and I don't know. I really enjoy solving these contests, talking to different people in different room systems. Really nice. So maybe come along next time and solve this contest with me. But now let's get started. Yeah, contest will start shortly. It's a bit. The community was grown recently, so server performance may be not optimal, I guess. But it's okay. I mean, it will start shortly. So we can just chill, drink some tea, I don't know. I believe we don't have to refresh the page, and it will automatically restart. But we can refresh in separate tab so that we see whichever one starts first. Okay. Consecutive ones, we're given a list of integers, we contain at least one, we return whether or once appear consequently. Okay. Let's get count segments of ones, also current number. The initial number is like, I don't know, nums 0. If num equals current, we just say, well, okay. Num not equals current. Yeah, actually, let's say, if num equals to 1, we add another segment of ones, I believe, and current number gets reset. Next time it will detect the change, and we can return like count of segments is equal to 1. Okay, first problem solved. Second problem, swap characters once to minimize difference. We're given two lowercase strings. We want to swap any two characters in S. We want minimum number of indices where SI not equals ST. Okay. I guess we'll have two strings in which n is going to be the length of these strings for then we can add corresponding characters. So first we filter characters that are like equal. Okay. Then what we would like to do is the following. Actually, what would we like to do? Like, how much the number of different spots can change. It can change by 2. It can decrease by 2 if we change like Si equals to Tj and Sj equals to Ti. Then we can decrease by 2. Okay. Let's actually create I would like to do the following. So whenever we encounter like different characters, I would like to append this position here. So we currently know what characters occur in which positions, I believe. And now we would like to do the following. So when we can increase and update 2 positions to improve the answer. Again, Si equals to Tj, Sj equals to Ti. Wait, actually, I don't understand what's the supposed solution in this problem. I mean, if the strings if these different characters have at least one character that's present in both, then we obviously can improve answer by 1. But whether or not we can improve it by 2 is rather not clear. I honestly don't understand how to check it quickly. Like sometimes we can, no, here we just swap B and get 1. But here we can swap A and Z and get difference of 2, which is really not clear. No, I don't understand. Let's take a look at the next problem. We are given a list of integers. We given a window and limit. Okay, so we want like we maintain a window and we want to check what is the maximum apps. Well, it's not particularly difficult, although I'm not sure how to do it in Python because I'll need multi-set. That's really strange set today we have of problems. So I have multi-set of this kind of things for we want to insert first window numbers, then for every next occasion, we would like to check that the multi-set should be like last should be the greatest, so we can subtract as such. We subtract this. If this difference is greater than a limit, we can immediately return false. Otherwise, we would like to insert nums window plus j, erase. I believe to erase, we need to actually find an element. But let me check the document. So multi-set erase Where is it? Google is stupid. Output, search output is stupid. No, okay. Wait, is there a version with... Yes, we can just erase like so. Let's see. So just maintain a multi-set of all numbers between, and maximum difference should be between. What happened wrong? What's wrong? I mean, should not fail, okay? Whenever, okay, I don't know what was that about. Potentially erasing something strange from the multi-set can give you an error. Intersecting lines, we have two-dimensional list of lines, integer, slow, high, okay. Each element is a slope and intersect, okay. Number of lines that intersect with at least one other line between x equals low and x equals high inclusive. Okay, so like x positions of intersect are quite fixed. They lie in some interval. You have like vertical sim going on, and we are interested how many pairs of lines intersect. Very, very interesting. How do we know if a pair of lines intersects? Well, they have to compare differently on different endpoints of the interval. So at low one should be lower and the other should be higher. Are we guaranteed that lines are distinct? I guess we are, because otherwise it's like strange. Okay, so my idea is that we take vectors of pairs of integers. First integer will be the coordinate, second will be ID. We grab that. Then I would like to iterate through all lines. And I would like to in place back. I'm not sure that I need right intersections. I would like to in place back following pairs of lines. Yeah, also let me just work on that. So line 0 times low plus line 1. Coefficients can be huge, I agree. Like something like that going on. I believe this is sufficient. And then we would like to have index. I obviously want to sort this. Once we sort it, we want to process this in some order, and then it will return answer. And answer actually can be in 64T. I have no idea why. Yeah, because obviously we can have like all pairs of lines intersecting. And that's 10 to the 10th over 2, it's overflowing. I have no idea why they return int. It just won't work. Okay. The idea is we loop over left intersections. We check for each intersection how many are bigger than that. And for that, we'll need std The idea is that if we loop through left intersections in sorted order, and then we compute like for each line what's its right intersection, and when we add new line, it will be higher on the left, and we'll be interested in how many lines it's below on the right. We're interested in order statistics. And I have a very neat trick that I am not sure whether it works or not. Because my idea is something that is not cross-platform, but it's really nice. Let me grab that data structure. Oh, I wanted to see my exact submission. Yes, and yes. Let's just give it a quick try whether it compiles or not. Well, okay, it will obviously won't compile here, but what's about the rest? Okay, so it compiles. So we have order at 3, which is very great because it means that we just have a method that will return order of key. So let's do it. We want order a set of integers. Well, it's already of integers. Right intersections for outer left intersection. Actually, these are pairs, right? First is what? First is left intersection. Second is line ID. We want to left intersect. Okay, whatever I called it. We want to do what specifically? We want right intersection order of key lines, line ID. Okay, yeah, again. We can grab ourselves a line. Order of key line 0 times 1 long times high plus line 1. Either plus this or plus the remaining size of this right intersections. Okay, let's see. Oh, okay, so I was wrong somewhere. Is this example present somewhere here? No, okay. We have like a horizontal line, whatever. It intersects at -2, -2, and we have -2. Oh, inclusive or not inclusive? Inclusive. Here at high, we have -1. No, here at, yes, here at high, we have -1. And here at low, actually, is it a multiset of right intersections? Let me think. I might miscalculated this. If we need multiset, then it's not very nice. Okay, yes, okay, I agree. We can get around this being not a multiset by providing pairs. So the previous one get counted as follows. We pair right intersection and yeah, we just need this kind of ID here. Insert, and here so everything with the same coordinate but if inserted before will count. -3, 0. Oh, this is really annoying. And we still get 0. Okay. No, we get 1, but we expected 0. What is this line on low? It's -2, -2. This line on -3, it's 6 -1. It's 5. Okay, so this -1, -2, -2 is 6, 5. Okay, potentially we want something like I minus this. So it worked here. Will it work on previous test cases? No, but then it does not work here. I don't understand. Like, we process lines in increasing order of left intersection. And we grab ourselves a line. We compute where it's its right intersection. It's above all. Yeah, just let me just print this thing. Know what line we are talking about. So here we have like this line at right is 5. This line at right is 2. And it does not create an intersection because they are increasing on the left. Yeah, let me just print like so. So we have first year line is 3, 5, second is 5, 2. And because it's above and it's below, it should count towards. It should count towards. And size by the current time is, yeah, I can print it as well. I believe size will be 1. Yeah, it's pretty reasonable that size is 1. Okay, so we have line 3, 5, which intersects with 5, 2. And then 6, 10 comes in. And it's the largest on the right, so it should produce like nothing. Okay. Actually, this is my first time using this data structure on the content, so it's expected. Okay, here, but again, no, wait. Why is expected answer 2? Oh, damn, we want only to calculate lines that intersect. We are not interested in calculating number of intersections, whatever. I believe therefore there is much simpler solution. Okay, okay. Okay, so we have like answer like this. Here, the line intersects with at least something if order not equals I, then answer line ID gets 1. So actually, if it's not minimum element, right? Then it, no, if it's not maximum element, then it intersects with, at least with somebody in the past. And then the very first element can't intersect with anything. Guess so we return. Oh, overcomplicating problems. Sorry, guys. What if we just count the number of ones if actually here we can just check whether it's max element or not. So yeah, because we did not insert. What can we in place? I'm just curious. Or this data structure is to all to in place. Okay. It's the same. Hey, but no. How is it the same? Oh, okay, okay. I'm not satisfied at all with how this is going. Damn. I forgot what the test case was. Why it's so inconvenient with these test cases? Why you can't run on multiple test cases at once? What is that? I have to manually copy paste it every time. And it's also, okay, whatever. I'm just at the platform, at the interface. But it means exactly that these two intersect. This line goes from -2 to -2. This line goes from 5 to -1. They intersect. What is wrong? No, wait, like this line at -3 is 5. Oh, no, okay, they don't intersect because this is above this, okay. But we take this How is the order not one? So what? Like here order is equal to I. And here as well. So where does it come from? I don't understand. Like count of ones should be 0. This line never gets executed. Oh damn. Because I forgot to plus I. Whatever. And what's going on here? Hold on. We have literally one place and we are happy if they intersect here. What if I say like so? This way it will get below the ones here. And also 0, 0. Okay. How? Just how? I don't understand. We are using literally the smartest data structure possible. This goes from 1 to 0, and this goes from 1 to 2. We are not counting them. How to count such intersections? I mean, we can obviously duplicate this code, but it's a very stupid approach. No, I don't want to duplicate. Well, maybe, okay. I mean, I don't know. If they simply have what's wrong this time? Hello? Oh, okay, because we are not comparing to first element. I believe this is terrible. This was supposed to be a different problem. A count and intersection is much more interesting. What's going on now? I don't understand. I just don't. Okay, this is stupid. Okay, whatever. And here we wanted to check whether or not we can swap two. Um, hmm. What if we actually store everything in sets? Then we can intersect these sets like so. Okay. Otherwise, we are interested in this. So if asset position char and D position from char intersect one measures my result is 2, possible answer is 1. Why? Because this is not correct. Like we would like to check. We would like to check that there is one character present in both strings. I don't know how to compare with empty sets. I suppose we can take len and compare to 0. Okay, at least we solved this. Now we would like to solve this. So again, how would we like to solve it? I have a very not useful tree, which would be very useful for if we needed to count intersections. I forgot what test case it was following, so let's just resubmit. I mean, there's no penalty for submission, so whatever. And also custom test cases are very inconvenient, so we just will submit all the time. So here we have line from -1 to 1. Order is 0. So this line does not intersect anything before it. And we have line from 0 to 3, which intersects which does not intersect this. It's 1. And we have line from 0 to -1, which intersects, okay. line. Okay, we like adequate way to do this would be to mirror everything, right? If right intersect, left intersect. Very inconvenient for town. Here we in place back this and this. We would then like to sort all of them. How did, okay, what's up? And it just did, yeah, you see, yeah, I clicked twice and it does not select what else. Yeah, I'm just, I don't want to see this problem any longer than necessary because it is super disappointing. I had a very beautiful idea in mind about better problem and they just, and this is just some random thing. It's not beautiful at all. Um, I guess we'll have like something like this. Yeah, I'm really not in the mood today for one variable names, sorry guys. Hmm. Is it set of integers or of pairs of integers? Of integers, okay. I would like to see the is element of ls. I cannot do like this. Then I would like to, no, actually, you know what? These are good. These are actually what I want both sorted and unsorted version. Because I don't want to compute coefficients all over again, intersections. So it's resorted if right intersections largest element of right intersections. We iterate in increasing order of left coordinates. So if a right intersection is at least rs at j first, answer at j should be true. At the same time, you should iterate over the other set at rj so. But here we iterate in okay, here should be the same thing. Here I insert into lefts. I don't know. Lens was not defined. What do you mean n was not defined? Okay. Where and why? Something can go wrong only if we access like elements out of order, but this is index. It is always an index. This. Okay. Correct. Before accessing elements of the set, we need to check whether it's empty or not. Why? We should count everyone. So it's really so when line can intersect somebody? If it's like we have line with increasing slope, let's say, and it intersects with lines with slopes like where left coordinate is greater, right coordinate is smaller, or left coordinate is smaller and right coordinate is greater. We should cover both of them in our if statements. Here we iterate in increasing order of left intersection. If right intersection is, if max right intersection seen so far is greater than current, then our current line intersects with something, and we count it. Really don't understand what's wrong. You don't necessarily need like this intersection. Yeah, if anything is a pair of equal lines, then we count it. Or do we count it like from both sides? It's like this. Okay, let me see. If I and left intersection answer j equals 1, answer LSS is 1 second, I believe. That's 1. The same goes here somewhere, like here. But this time it's RSS and it's RJ. Like now we should be counting every pair that has equal at least on one side. Very slow and very slow. Or actually we are 16, but it means like very slow. We are the last to finish, right? And also, obviously, Salvo finished, Lucifer, Laurie finished. Even Isaac finished. Congratulations to Isaac. Isaac solving some problems faster than me. It's great to see. And also in the same order as me. Oh, actually, a lot of people skipped second, solved window first, and then this. Okay, it's a bit confusing. Like, I initially thought that we want to count all intersections, and the way to count is we want to have a set that provides order of element by key, and this is implemented in C++ on GCC specifically. GCC has a lot of things hidden under the hood, and one of the amazing things is ordered set that we see. But unfortunately, we only want to count number of lines that intersect something, and it was not necessary to have that fancy data structure. It's essentially the set, like red, black tree, but it carries additional information in the vertices, which allows us to restore the answers quickly. Okay, whatever. I should read statements more careful. But that problem would be interesting. I actually think it should be good. I have one interesting idea. Nobody's going to like it, but if it's solvable in some fancy time, that sometimes maybe we'll see this on code forces. Let's see. So quick recap, consecutive ones. We maintain current number, we initialize it to something dummy. Whenever we encounter like new segment of ones, is when a number is not equal to C, but number is equal to 1. Then it's a new segment of ones. We just maintain the current number. Here, dia is for every position, for every character in alphabet. We remember all positions where first SI and DI are different, and second SI is equals to this character. This map is from character to positions in string S where this character appears. Then remember that I was talking about that idea that we want SI equals TJ and SJ equals TI, right? So essentially, like this is character 2 and this is character 1, right? Because iterating over positions would be very slow, we iterate over characters instead. Like these two operations are 26 characters in an alphabet. And then for each such thing, we want to check set intersection. That's obviously a slow way to check set intersection. I mean, we can check set intersections in this case, I believe we can speed up it with bit sets like 30 times. Also, I'm not sure whether this set intersection in Python is linear or not in the size of the container, the sets. And then, like, if we are unable to find this, which reduces the number of different positions by 2, then we have to settle down for one position. One position is possible when we have one character appears in both strings as incorrect character. Will it change our, I hope it does not change our standings. Yes, okay, whatever. Like this is simple sliding window. We just needed to switch to C++ because I don't remember what is analog of multiset in Python. So we initially insert some prefix of given lengths, and then we insert new, remove previous, so it's a sliding window, and each point we check the max element in multiset minus smallest element, which are reverse begin. Their difference is not too big. And also we need to check it here after we edit the last step. And here, the idea, let me draw because it's important here. So when two lines intersect, one of them is above here and below here. So I say, let me process all of these intersections in this order. Here's left boundary, right? Low, x equals to low. I process these guys like this, and I insert their right endpoints into set. Now, when the next line comes around, like it's guaranteed to be above here, and I want to check whether it's below anything here. If it is, and it's conditioned like less than or equal to max right position so far, and this line intersects something. Okay, and then I go the same on this side to count this line as well, because its left endpoint is not max, and it means it intersects something. And also we needed to add like tricky conditions. What if lines intersect not like this, but like so? If we were to count only one way and the other way, right? Like when going this way, upper would be counted. When going this way, it depends. Maybe lower would be counted, maybe not. It depends on the order or in which this ended up being here. So we also check for equalities. And my original idea, I misunderstood the problem, I said that we want to count the number of intersections, which is really cool because like how many, suppose that we again go in this order and like insert this, right? We insert right endpoint in the corresponding set. So far, no intersection. We insert this. We insert this and we see that, well, this is above anything previously seen, right? But how many lines does it intersect? Well, it intersects everything that is above it here. So we want to have a set that you can ask an element and it will say like how many elements I have greater than that element. That's a really nice way to implement this in C++ is to use tree from GNU policy-based data structures. And I just thought that this is what we want to do, and it would be really nice. So here, for example, like this data structure answers 1, so we count one intersection. Then we add this, and we ask for this. It says like 2 because both of these are above, and we indeed count these 2 points. Here we ask this. It says like, oh, everyone is above, so we say like 3, and we indeed count 1, 2, 3 points. Also, no, it counts number of pairs of lines that intersect. It does not count number of points of intersection. In the minute that you can have like 3 lines through 1 point, it will count them as, well, this is line A, this is line B, this is line C. It will count like A intersects B, A intersects C, and B intersects C. So it does not count points of intersections, it counts pairs of lines that intersect. And it's really interesting. It would be really interesting to see this in action. But it turned out that everything is much simpler. So we don't need, we just want to compare whether it's max or not. And set is sufficient for comparing with max because you can access max in O, big O of 1 in constant time. Here, each of these operations in the usual set, if you think like, oh, wait a second, we can just maintain a regular set and find, and then take distance. Well, distance on set works in linear time. And the data structure that I suggested, it returns order of a key in logarithmic time. Obviously, linear time would lead to like this loop and also this. if this was like linear, then we would have quadratic time, which is not suitable for n up to 10 to the fifth, but n log n would be exactly what we needed. So yeah, that was it for this contact test. I mean, we solved everything, which is nice. Let's head on back to the discussion. Sometimes contains very interesting things, but and I'm not sure whether it's my internet that is lagging or something else. Okay, not so laggy. No. Yeah, it was a really nice contest if I could read the problems. Yeah, it would be a really nice problem. I mean, you can solve it without this data structure, but it's really convenient that it provides order of key. Yeah, and I believe Saucon goes through problems on Twitch. So you will have a choice between two different explanations. The choice is always good. You can listen to his Twitch stream now on, or you can like refresh later, see my video on YouTube. And I guess this is it for today. Nice problems if you can read the statements. Okay. Yeah. No, I mean, it was like, I don't know. It's my fifth contest this week, and the further we go, the worse I read the statements. But whatever. It was a lot of fun. Yeah, also we solved everything, so it's okay. Hope you enjoyed. Hope these my explanations help you a little bit. That's it. Come and join bannersearch.com. It's real fun hanging out with different peoples. As you can see, they have like room systems in which a couple of different people are basically solving virtual contest, which is interview themed. Very cool. I really suggest if you're like preparing for some interviews and want not to simply solve problems, but to hang out with people, ask questions. There are a couple of people, several people who are like not worse than me, potentially better in this kind of questions, like obviously Sawu. Uh, I guess a couple of people named Lee. This is the first Lee, and I believe there is a second Lee somewhere around. He's also a cool guy. Obviously Lawrence and Jay. I'm not sure that I pronounced Jay correctly. Is it Jai or Jay? Jay. Okay, so I hope he doesn't mind. Whatever. Yeah, sorry for that, if it's not correct, but whatever. So really cool problems. I mean, a lot of content from lead code is here. And also this platform is completely free. So that's it. I guess I'll head to Sau's stream and check whether he knows like how to solve the count intersections problem. So that's it for today. Hope you enjoyed, hope this helps, and see you next time. Bye-bye.